What we're going to talk about next are the main building blocks. If you remember briefly when I told you about what we're going to talk about, I said main building blocks is basically the things that we use to build Android apps, right? So Android is based on Java. So you got all the Java constructs. It's based on Linux, so you got some Linux constructs and so forth. That stuff is old news, right? Main building blocks is totally new. It's things that you haven't seen before in any other place, right? So it's purpose-built for Android. Now, to kind of explain what it is, first, what I'm going to do is I'm going to show you an app that I have here. It's called Yamba, and Yamba basically stands for yet another microblogging app. So that's basically the acronym. And basically, I'm just going to use it in the context of explaining what it is. So Yamba is actually available on GitHub. So who's totally new to GitHub? Hi. Okay. Okay, so you guys know what source code repositories are and so forth, like ways to manage source code repositories, versioning, right? So we have a we use that for distributing the code as well. So and GitHub is basically just a kind of like a repository where you can also access it. It's centralized, right? So you can access it. You can share the code easily, right? It's actually the GitHub company is just down the street on Howard. So you can, if you walk down, you see a little green door, you knock. So they're right there. So this is the location that they have for the source code. Want to see a cool thing that is very useful? Check this out. Let me do this. Go to this URL. github.com/gist. Oh. No, it's not just. What is it? Yeah, sorry, it's changed. So that's the URL. Okay. So Android. Hold on 1 second. So the bootcamp December 2011. So notes. Oops. Okay. So you can go to this URL and keep it open. Got it? So what I can do now is I can give you useful links and I can just copy paste them. So for example, this is where I can basically go here and I can edit this file. I can now say, actually check this out. Let's see if this works like this. GitHub replace. Oops. It doesn't even use markup. Yeah. Okay, so you can. This is the repo that you can go to. Well, now if you refresh that page, right, you should be able to see it. But that's you should be get you get a page like this, right? So that's where the source code is for the book. So Learning Android book. This is the source code. It's right there. So what I'm gonna do is I'm going to download this. Let me think about what the best approach is. Yeah, I'll just do that. I'm not gonna clone it, but I'm gonna download it. Okay. So you can download this source code onto your computer. you can click on the little download tab. Click on download as zip, for instance. And that's just going to download the zip file onto your computer. I'm sorry? You guys should have now a file somewhere on your file system. Like for me, it goes into a desktop, so it's going to be a file called something like this: Maracana-learning Android Yamba dash and then some code.zip. That's the checksum for this file, basically, for this version. Okay, you don't have to open it. So what we're gonna do next is we're gonna do this in Eclipse. So go to Java perspective. You can close everything related to hello Android, hello world, right? So far so good. So here's what you can do. You can right click, or you can do this: File, Import in Eclipse. Right? Click on Import. And now what we're going to do is we're going to point to that folder that that zip file that we downloaded. So you're going to say General, Existing Projects into Workspace. Okay. You click on Next, and you can actually say Select an Archive. So you can actually import directly from an archive. Okay. And you can click on Browse, go to your desktop or downloads directory, point to that folder, and that should identify all the possible projects in there. So Yamba 1, 2, 3, 4, 5, 6, 7, 8. That worked? Yep. Click on Finish. And what that's going to do, it's going to basically import from that zip file all the files, all the projects into your workspace. So you should now have a whole bunch of things in here. Okay. Got it? Now this is gonna, it may be broken initially. So what you need to do, first of all, it's probably building in the background while we're talking. Okay. But what you may need to do is, if there's a little a red thing, you may have to go to, well, let's see. One way is to try to do this, fix project properties. And if that doesn't work out, then what you can do is you can go properties and make sure that it's based on an API that actually works. So the point is, I want to figure out why it's not clean. Yeah, well, they're supposed to miss gen because the gen it should be auto-generated. I don't check it in. All right, so do this. Project clean. It's just Eclipse is not smart enough to recreate it, because I purposely didn't check in stuff that doesn't need to be checked in, like gen and bid folders. Yeah. If you're still getting an error, the other problem that could be is that when you do a project, you have to specify a target. Remember how I said you need to have at least one? Well, it's possible that the target that I used is not a target you may have installed. Like I think I used target 8 and you only have 10, for instance, right? So the easy fix is you right click on a project and you can go on the properties and choose one of the things that you have, right? Because indeed I did specify 8 in my original code, and you may not have downloaded Android 8. Don't worry, you don't have to download it. Just go to use some other version. Okay. So a couple of things I would do to try this, and it's going to depend on different computer may behave differently. right click on a project, go to properties, pick something on that list, right? Your list is going to be different than my list. The reason is I built this for Android 8. That was the latest at the time I did this. You guys may not have Android 8. That's why first you need to do that. So pick something that you do have, like Android 10 or 14. Click apply, and then click OK. Because it seems like if you don't click apply yet, it actually doesn't make it sticky sometimes. Then you could also try project. So right click and say Android tools, fix project properties. That's also supposed to be a little intelligent about adjusting things that are different between what I checked into GitHub and what you have on your desktop, because there could be a discrepancy, right? Yes. And after do that, you can do project clean, which would force it to basically rebuild everything. So it's kind of a, I mean, Eclipse is not super smart about that, but you know, these couple of steps should help you import all that. And then let it build, because ultimately it's going to take it some time to recompile everything. But the little X's should eventually disappear. So again, we're not really going to look at this code right now. This is more just to illustrate an app, right? So what this app is that I'm firing up right now is Yamba 8. It's one of the versions of Yamba. Remember, it's basically a Twitter app, right? So this is loading up. Bam. So there's Yamba. So what I just want to show you is from user standpoint what it is, right? So there's a timeline. This is basically, you know, remember this is like a microblogging Twitter app, right? So this is where you would see what your friends are doing, right? This page here would be what I would get if I go to Twitter and I can kind of see, you know, what's going on in the world, right? And so on. Oh, Sigurd said something. Oh. So that's Blake's a co-author. So okay, so there's nothing here, right? So that's because I haven't updated my username and password. So what I'm going to do is I'm going to click on menu, and I'm going to go into preferences. Okay, I'm going to provide username and password. So username is student, and password, come on, stop. Password is, don't tell anyone, it's password. Okay. Now, we are not really using Twitter. Again, there are a couple of reasons why we're not using Twitter. For one, if I had a class like this and you guys all use the same username and password and try to do what we're gonna do, Twitter would really quickly shut us down. We would get rate limit reached, right? So it's not very conducive for learning purposes. So that's one reason why we're not using Twitter. Second reason we're not using Twitter is that Twitter doesn't allow you to log in with username and password anymore. Right? If you write an app, you can't use username and password, simple authentication. You use OAuth. How many of you know about OAuth? Okay, exactly my point. So not many people know about OAuth nor how it works, and it's actually a pretty involved sort of workflow. And it's not what I wanted to teach you. It's not related to our class. So that's why we prefer just to use username and password, which everyone knows, right? And so we run our own service. That service has an API root, which you need, of http://yambamaracana.com API. Okay. So that's where the service is running. So yamba.maracana.com/API. So then press OK. So basically, this now is looking at that location. Now, if I click on menu, refresh, this is hopefully going to get the data from that service, and there it is, boom, right? So there's the data. Okay. Yeah, I'll take a look in a second. So there's a third screen here. You can click menu, and you can say status update, and you can say hello from SF. Okay, click on update. Okay, so that's posted. Since we're not using Twitter, we are using this other service. You can actually go to yamba.maracana.com, and boom, there's my post, right? Make sense? So we can actually verify that this worked. So the point of this was to show you a sample application, right? So in the context of this, we can now look at some of the main building blocks, right? So we have a very simple application. It has a way to post a page. It had a way to see what your friends are doing and change preferences, right? So with that, let's talk about some of these blocks. So one of the basic things you have is something called activities. Okay? So activity is roughly a screen, right? Like one activity is roughly a screen on your in your application. Your app could have multiple screens, right? Most likely it will. And so you could have multiple activities. You could have a main screen, like sort of the entry point into your app, right? That worked? Oh, cool. So don't shut it down. Yeah. So I kind of compare activities to web pages. So just like a website can have many web pages, and you have a home page, so your app can have multiple activities, and you can have a main activity, right? But it doesn't mean that somebody has to come into your website via this activity. If they know a URL, they could come in via this activity, quote unquote URL, right? It's not really a URL. So you guys saw in that previous app, you saw 3 activities. You saw status update, you saw timeline, and you saw preferences. Right? Now here's the tricky part. Activities have a life cycle that's managed by the system. And it's a fairly complex life cycle. So first of all, the way we program in Android is different than what you guys may have experienced before. Anybody has experience programming applets or servlets? Okay, so you do. So you know how when you're programming applets or servlets, you're basically programming in so-called container environment, right? Something else is running your code. It's not like just a main method, right? But you have init, start, stop, run, destroy, or something like that, right? You have all these callbacks that you implement for your code to respond, right? Okay, so here's what happens with an activity. At the beginning of a day, your activity is not running, right? So it's in a starting state. Then the user says, okay, I want to start this thing, clicks on the button. Eventually, that fires up your activity, right? To get from here to there, the system is going to invoke a whole bunch of methods on your activity, on create, on start, on resume. So each activity has these methods. They may be empty, but it has these methods. So it's an opportunity to do something, right? Now, at some point, so you have an activity now in your foreground. You're looking at it, and you can basically have how many activities active at any point in time? Yeah, you can only have one activity ever active. So this means that it's the one that's in focus. It's interacting with the user, right? The user can actually type something in, right? At some point, you may say, okay, I want to pause. I want to switch. I want to go to another screen. So what's going to happen is your activity is going to get paused and stopped really quickly. So this is sort of like a very temporary state. This is a state when your activity is partially visible but not in focus. Right? The example would be like a dialog box came on top of it. Something that is mostly obstructing it, but you can kind of see a little bit around it, right? So it's not a very common state to be in. You pass through it really quickly, right?
What about soft keypad?
Soft keypad?
Comes up, Is there activities?
That's a good question. I'm not sure. I'm not sure. I mean, it's implemented by a system, so I'm not sure how that is treated.
Your activity running in the background.
Yeah, your activity is still going to be in a running state. So in that case, yeah. So at some point, your activity is not visible, but it's still in memory, and that we say it's stopped, right? So it's not visible, but it's still hanging in there. Okay. So you can have many activities in this state, right? There could be just many activities just lingering around.
Who stops?
So who drives all this? Well, it's the activity manager. So there's a system process called activity manager, which watches all the activities and decides which one is going to be in the running state, which one is going to be stopped, or which one is just going to be disposed of altogether and be gone, right? So you guys don't have a quit button in Android, right? You don't get to quit an application. Right? So this decision, what gets destroyed and when, is totally up to system. Does it work like a thread? Not really. I mean, you're gonna have a single thread to run all this, but no, it's. I would compare it more conceptually to garbage collector, right? So just like garbage collector has its own heuristics on when to mark and sweep objects that are not being used anymore. So does this. It's got some logic that basically says, look, I got some classes here lingering around, haven't been used for a while and use a lot of resources. I'm gonna dispose of them. Yeah, it's like a poll. Yeah. So why do we do it this way? Well, because this process from starting to running could be fairly involved, right? To get from this state to that state, usually you have to start a whole new Linux process. You have to load up virtual machine on top of it. You have to instantiate your classes. You need to load up your XML, parse XML, draw the objects, draw the screen, right? So these steps here tend to be like super expensive. There's a lot of work that needs to go into doing all that, right? The fact that we're now switching from screen to screen shouldn't mean that we should just get rid of it. So that's why we don't have this, right? Or this. So we don't have those because they don't make sense, right? Because that would just dispose something that we spend so much energy doing, right? Rather, what happens is we keep them all around in stop state in case that we want to go back into running. So this tends to be substantially cheaper steps because we already have everything in memory. We just need to redraw it. So the question is about multitasking. So what we are talking about here, first of all, is the activity lifecycle, not an application lifecycle. So it is true that you're not going to be able to have two activities running at the same time, right? It's not true that you're not going to be able to have two applications. The applications are different constructs. They actually run in separate Linux processes. So Linux is going to give you that multi-threading.
So you could have two or more in the stop state.
Yes. Yeah. Now, let me rephrase something again. That's important to understand. The fact that we call this one running could be extremely misleading. It's more appropriate to think of it as visible, because an activity that is just sitting there waiting for you to like type in some information or something is really not doing much. It's very much idle, but it is in a running state because it's in focus, right? Similarly, the fact that this one is called stopped doesn't mean that it's not running. I would rather use the name invisible possibly than that. So for example, you could have things that are in stop state, in other words, not visible, but they're still cranking, like doing a lot of work, right? So be mindful of that. One thing that's I can use an example is there are certain operations that are extremely expensive in terms of the battery, right? Let's say, for example, you have some app that's using GPS, right? The way GPS works, or sensors for that matter, is you subscribe to something like GPS updates or sensor updates. And then as you get new data, the data is just pushed back into you via callbacks, right, that you then need to process. Well, GPS could be providing a lot of information all the time. So that's using your CPU, and it's also using the GPS chip, which tends to be very expensive on the battery, right? So when you're doing something like that, you got to figure out when would you like to really use GPS in this context, right? So I would argue, like, if I want to be sensitive to a user and the battery, I would probably use GPS just while in this realm here. Okay? So if that's the case, then when would you turn it on? Well, I would say let's turn it on in on resume, because all the roads into running go through on resume. And let's turn it off in on pause, because all the roads out lead through on pause. Make sense? So basically, that's one way to do that. To have the to use the callback methods to manage that, to turn some stuff on, to turn some stuff off, right?
What if it takes a very long time to turn it off? And if you wanna, I mean, is on pause is synchronous, right?
This calls are synchronous, yes, and it does not take that long to turn it off, because you're just basically unsubscribing from getting notification.
I'm just making up. So if something I'm controlling, it takes a very long time. So which I don't want to do it on pause, then can I just kick off some async thread and
Yes.
turn it off before
Yeah.
pause?
Yeah, you can do that. Yeah, asynchronously. Yeah, via doing it on a separate thread. Yeah. So everything in this context happens on a single thread. We'll talk about that later on. So-called UI thread. So does this make sense so far? Yeah.
So is activity a UI sort of abstraction, or is it a learning process abstraction?
It's more of a UI. If you look at it like that, it's more of a UI thing. So an activity is the only visible main building block. It represents essentially a screen, a unit of screen.
But the functions actually indicate it's more of a business logic abstraction, because on creation, I may not only add buttons, I could do some business logic, which is contact the server and initialize stuff.
Yeah, you could. So these methods, you can do whatever you want. So it's not just using the creating the UI, but it could be initializing connection to Twitter, for example. Yeah, absolutely.
So is the idea that the in sort of web technologies, the view and the sort of model or controllers are compacted into a single entity?
So the model and the controller, we're not really splitting it that way, and the patterns are not your standard MVC patterns. We'll talk about some of that stuff, how we could design it differently. But there are certain patterns that are familiar, but not your typical MVC. So I think, well, we're gonna probably find ourselves coming back to this slide quite a bit, because this picture is it's kind of like peeling an onion. There are many layers to understanding it. So we'll get back to that. Just in terms of the memory consumption, what you also need to know is that this guy is guaranteed all the memory and resources in the world. To a certain extent, this guy, but everything else is not. So this guy could be wiped out at any point in time. Right? The stopped one. So highly managed in lifecycle, and you respond to callbacks.
What exactly? If I just simple UI app running, is it going to stop?
Yeah, it's going to be stopped and destroyed, and removed from memory.
Oh, okay. So
garbage collected, the whole 9 yards. Yeah.
So it's basically start from scratch then.
Yeah, exactly. So it doesn't matter if your user restarts it. User doesn't care if user got in like this or possibly even like this. Shouldn't matter. Right. The idea behind this was that the design decision behind this was that users should not be managing memory, right? I mean, when you think about it, when you use your Microsoft Word or Excel, right? You start it, like you go to start and you start the application. Then you tell yourself at some point, you know, I'm not using Word, and Word right now, and Word is taking too much of my memory. And then you go and you shut it down. Why do you do that? Because you want to free up resources on your own Windows computer, right? So in other words, what you're doing inadvertently is you're managing the memory of your computer, right? Well, we shouldn't have to do that. Just like you don't change gears on a car anymore, and you don't allocate or in free memory anymore, right? Right? Algorithms do that for you. So this is the idea behind the design of Android. So users should not care how something got started, if it's running in the background and so on. The system should take care of that. You just want to see the app. You want to get something done, right? That's the philosophy. Make sense? All right. So that's a little bit about activities. Let me explain another concept. It's not really a building block, but it's used internally quite a bit. So it's a concept of an intent. So basically what an intent is a sort of like an event or a message that is used to glue main building blocks together. So it's used to glue, activities and services and broadcast receivers and content providers, all these guys together. Now I'm using it in a context of activities just because it's easiest to understand, because they're visual, right? So let me kind of walk you through this. So let's say I am looking. I'm checking my Gmail, right? I'm in my Gmail app, and I'm looking at the list of messages, right? Oops. Hold on a second. So I'm doing this. So I'm checking the list of messages. So we're right here right now. So basically, I see a message that I like. I click on it. What happens next? This activity is going to go from running to stop state, right? Make sense? Another activity is going to go from God knows where to start to running state. We don't know which way we're getting back into running state, nor we care, right? It's going to come back to running state. So I'm now going from list of messages to a particular message. Let's say it's a message you sent me. So I'm now reading this message, and it says, oh, check out this story about Android taking over the world, right? So I click on that story. That now opens up another activity. So now this one is stopped, this one is stopped, this one is now running, right? And it's a web view activity, and I can actually see the story, the web story, the web URL, right? And it's an article about Android taking over the world. And inside of the article, it says, oh, see the video clip, right? So I click on that, That now opens another activity. So this is now stop, stop, stop. Maybe this is destroyed. Who knows? Maybe this got destroyed, right? But now we're in viewing another activity in which we can view the video, right? And you know, I click on that, and it's like you can see the little androids coming out and taking over the world, right? So basically, what I did is I went through 3 applications, and across that I did 1, 2, 3, 4 activities, right? And basically I completed a task. What made this possible are intents. Like they kind of glued the whole task together, right? Now, an intent can be explicit or it can be implicit. Explicit intent is you spell out what you want to do, right? Like in this case, we spelled out that we want to open up a particular message in the Gmail application. So that's why it handled it using the Gmail's own message view activity, right? Now, when I clicked on in here to open up a web browser, I didn't have to specify a specific web browser. I just basically said open up in a favorite web browser, right? So it could have been Firefox, it could have been the built-in browser, it could have been Chrome, right? So that is not important. System is going to resolve it. So that's an implicit intent. Similarly, here when we said I want to view a video, it opens it up in whatever browser you want to use.
Can you direct those to specific places? Like for example, like if you click a link in the web browser in Android, it'll give you the option. Do you want to open this in the browser or in Maps? Obviously, in Maps, but in the app developer, do you control that, or do you always does the user always get that choice?
Yeah. So as an app developer, you get to say how you would like your action to be handled. So this guy here is saying when the user chooses to open up a web content, it should be handled by whatever is capable of handling web content, right? So if you have one browser, it's going to open it up with that browser. If you have many browsers, it's going to prompt the user and say which one would you like, right? You as a developer cannot and should not be able to not allow that, because that's kind of like Microsoft not allowing any browser other than Windows on it, right? So that would not be a good thing, and you can't do that.
So technically, you cannot do it.
No.
It's not possible.
No. No. If you want to open it up with your particular thing, then you would use you would spell out open it up using my browser.
If there's a tool like activity application separate, then can I explicitly send an intent or pull out that activity?
Yeah, you can. If you want a specific one, yeah, you can spell it out.
I can spell it. Well,
But you can't say I wanna open generic HTML page using a specific browser. You can say I wanna open up this using this browser, but you would spell it out, yeah. And that's the case here. So in this case, right, that's explicit, right?
So in terms of this life cycle, what if you have a back button?
So the back button is just gonna go back in the task list.
Right, but so it would do the start activity again. The start.
Yeah.
method.
Yeah. All the way to the home screen.
So which means that let's say if in your start activity you are let's say getting something from the internet, from the cloud. Every time you hit that back button, you're again going and fetching stuff.
Or if you go back to the browser or something.
Well, let's say in this Gmail, the message list activity. So if you're in the view message and you hit the back button, it goes back to the start method of the first activity, which is the message list activity. In that case, you will again be going on the net and fetching the list of messages.
So if I'm clicking the back button, so presumably the previous stuff hasn't been disposed of and it's still on the stack, then if I'm going back into running by clicking on the back button, you are going to go through these methods. So it's going to call on restart, on start, on resume. So if it's going to fetch something from the web or not depends on where you're fetching. As long as you're fetching in one of these three, yes, that's correct. But if you're fetching in on create, no, it's not. That's why you have the opportunity in which one you want to do it. Or if you do it in on start, it's not, right? Well, actually, sorry, on start at all, but yeah. Yeah.
When you call the on pause method, do you have to, as a developer, keep track of the important state of that activity? Or does the system remember that when it is called on one user?
So the question is, if you if you go through a pause and then resume, if you have to remember the state? It depends on. I mean, system is gonna, your object is still in memory, so it's gonna retain its state. So no, you don't. I mean, the state is gonna be retained. But let me give you an example. If you rotate your screen, like if you do this, Control Shift F11, sorry, Control F11, okay? So I rotated the screen, right? What just happened is this. So we went from here initially to here, right? We were there. When I rotated the screen, it actually did this, did this, did this, did this. Recycle the entire thing from scratch, right? I simply just rotated the screen, right? So it destroyed everything and recreated everything.
But the time that took didn't seem to be that it went through this entire cycle.
It takes some time. It actually is kind of slow-ish.
It's very slow.
Yeah.
So that means if you want to do, let's say, any caching of data, on pause.
No. So there are some other lifecycle methods. There's something called on save instance state and on restore instance state. And as a matter of fact, if you guys remember in our hello world, our on create method, this guy here gets a bundle. And this is the only, so this is one of those lifecycle methods, right? We keep talking about them here in a picture, right? So here we have them in a picture on create, on start, or resume. This is what it looks like in code, right? But this one actually has some so-called a bundle state, which is basically normally null. But if you're going through that reincarnation, it's an opportunity for you to leave certain primitive data for your future self. Right? So if I know I'm gonna get rotated and killed off, I could say, oh shoot, like this is my state, retain it so that the next guy can resume there. Now, do you have to do that? Not really, because a lot of form elements are gonna memorize their own state. Like if you have just a text field, like it's gonna memorize its state and so on. But some may not. Like for example, playing a video. Like if I'm playing a video, say I'm playing a movie, and accidentally rotate the screen, it would actually start from the beginning. So what I would do in that case is I would actually maybe retain the current position, right? Store it in this bundle. Upon recreation, pick up that information and continue where seek to and continue where I left off. To kind of make it look like it's all smooth, right?
So these kind of interruptions could be not just rotating the screen, but let's say you receive a message or phone call or anything.
So receiving a message is not, well, SMS not really going to do anything, but a phone call, yes, it would cause your activity to be stopped and started. But it doesn't mean that it's going to go through an entire cycle. It could actually go from here to this and then recreate. But in other words, it's not doing this and it's not doing that. So in other words, your object hasn't been garbage collected. It still has its state.
So is there a way to check whether it's still in memory or it's stopped and destroyed?
Well, I mean, you would know based on which methods are called, right? So if it's going through on create, then it's not in memory, right? So you don't need to check because you know the callbacks, you know the structure. You can also change the default behavior. You may say, look, that whole rotating of the screen thing, that's crazy. We don't want to do that. We don't want the standard behavior of destroying everything and restarting everything. So you can override the those defaults. You can say, I'm going to handle my own screen rotation and do it differently.
So the screen rotation, that always call it destroy?
That's the default. Well, no, yeah. So that's default implementation. Yeah. So far, so good on this? Yeah. Okay, so let's do this. Let's take a short break because I promised you guys 3 o'clock, and then we're going to continue. We have basically 2 more main building blocks. No, 3 more main building blocks. We covered activities. We still have services. We have the broadcast receivers and content providers.
Actually, after break, maybe I always get confused with the launching mode, like single time, multiple, single test. Can you cover that?
The like single top multi.
Yeah, that's always confused. I still not really clear.
Yeah. Okay. Okay. Sounds good. So let's continue. You guys were asking some good questions. So a couple of things I wanted to point out also here is that this is guaranteed to be called. This is not guaranteed to be called. No. No. So as a matter of fact, like if you really want the details on this or somewhat of the details, let me point you to 2 places. One is the official documentation, which is basically, remember I said this website is going to be a friend, right? So if you go under activities, the talk about the life cycle is actually outlined here, and it talks about what happens when, right? So that's basically what goes on, right? So it tells you here if it's guaranteed. So killable after. So basically after on pause, right? Your activity could be killable. In other words, gone. It's not going to be cleanly destroyed. So in all these states, it's killable. On pause, on stop, on destroy. Right? It's not very likely it's going to be killed in on pause. This is very sort of like sudden death because it's still partially visible. So you don't. It will freak user out. Like if something that's partially visible just disappears from the screen, but it's possible. So basically, yeah. So that's the official lifecycle. Now what we've done is we wrote a little example code which, well, if you care about downloading it, let's do this. If you care about downloading it, remember GitHub. There's another repository which is kind of useful, but let's download it later because otherwise you're going to spend time now downloading it. But I really wanted to show you is the sorry, the courseware Android out. There's a file that I put called main building blocks. So what I did is I wrote a little program called Lifecycle Demo, and I ran it through various scenarios that I could think about, and I documented that in this document. So basically, I ran it through starting activity first time. What happens? Let me actually show you this in HTML format. It's actually easier to read, right? Okay, better than paper. So, if you look at it like this, right? So, first time starting activity, create, on start, and resume. What my program simply does is just logs, right? So it doesn't really do anything else. Just basically says I was here, right? So just logs. So what happens if when you start when you started one activity, but then you start another activity? Okay, so you go through on pause, stop, restart, stop, start, resume. Right? So you start another activity, go back. So you pause, stop, then coming back, restart, start, resume. Here's the rotating of the screen. Remember, you rotate the screen. Pause, stop, destroy, create, start, resume. Right? So in other words, we went through the entire life cycle. Right? Pause, stop, destroy, create, start, resume. Right? You know, right? So that's that path that we took to come back. Make sense? What is meant to do, you know, on create different than on start? So it's a good question. So see how on create is only called once. On start, on the other hand, it's going to be called here as well as here. So in other words, it's really up to you what you're going to do when. So for example, you, like let's say you are establishing connection to a database or to Twitter or to some web service or something like that. Where are you going to initialize that? Are you going to initialize it, you know, here, or you're going to initialize it here? I mean, this way around it doesn't matter. Both are going to happen. The question is, should I reinitialize it when I'm going this way, right, or not? So those are the kinds of decisions that you have to make. Practically or pragmatically, like what happens out there in the real world is that universally you almost always care about this guy. Almost always. It's very commonly used method, right? And you can think of it as a constructor or init, right? You always care about that one. I also find myself often caring about on pause and on destroy, on resume, because they're kind of like the opposites if you want to keep something just in this state. Just like on start, on stop are kind of the opposites, or on create, on destroy, right? Kind of make sense? So that's what I find, but I find myself using this a lot. Like for example, if I'm dealing with sensors or GPS, like those examples that I gave you, I would use that.
So the system doesn't really care what you do within these methods, but what it does tell you is here's when I'm going to call them.
Exactly. The system doesn't tell you what to do with these methods. They're empty. Like, you know, not technically they're not really empty, but you subclass them, then you add your stuff, right? So it's a different way of programming, right? Because you're not saying you don't get to say what you want done, right? You don't control which state you're in. You can't control, am I here, am I running, am I destroyed, right? It's kind of counterintuitive, like I can't kill my activity, right? But you do control the transitions, right? You control what happens en route from one state to another, right? Those are the things that you control. So it's kind of like knowing this state diagram, it gives you opportunities to be reactive to changes in state. But it doesn't give you opportunity to pick a state. Okay? So that's where it's different. It's a different way of programming. It's kind of like event-based programming or whatever you want to call it, right? Your code is just there to respond to when something happens, right?
In the on-stop method, I could call the on-destroy.
You can't call. You don't call any of these methods. System calls it. The activity manager calls it. Yeah. So if one activity you have multiple fields, they're just going to be objects within that activity object. So they're just going to be objects. That becomes a plain old Java. That becomes a plain old Java. This is where it's a little more meta, higher level. Sorry, just 1 second. Yeah. Yes. So it's that's what I said. You know, conceptually, if you guys program in a container environment like EJBs or servlets or applets, where something else drives your activity, the state of it is external to the object itself, then maybe conceptually, similar to something you experienced before. Yeah.
Let's say in your application something misbehaved when you wanted to stop the activity, right? I understand this is the concept of callbacks, but in the end stop method, I could still call on destroy.
You can't. You can't call.
You can call like destroy, and you'll call on destroy. Right?
Yeah, you can hint to the system that you would like something to be destroyed, right? That's how the task, like advanced task killer, for example.
No,
You guys.
I'm talking about activity. You can actually have the function called destroy.
The function called destroy, it's going to still suggest to the system to destroy it. So destroy is not, let me see if it actually exists in the activity. You can't do it that way, but you can do it via the activity manager, the local activity manager, and then you could dispatch. So you could basically say destroy activity, but this is basically this would basically hint to the activity manager to destroy it. So you're basically telling the system to destroy something, as opposed to you destroying it directly. And it's probably going to require permissions, because not everyone can just yeah. And this has been deprecated by Fragment Manager, but that's a different story. So did you have another question, no? Oh, okay, cool. So a lot of this stuff is sort of not very well documented, so that's why that little code that we just wrote was just meant to kind of test some of these assumptions, like what happens. I think you had a question earlier about single top versus multi-top, like what happens if I start an activity, then I start an activity again. And we'll get into that again like a little bit, but you could actually have multiple instances of an activity, and they just kind of like they end up like on a stack. Right, so it becomes this situation where, yeah, it can get confusing if not implemented properly.
So in the manifest, we have to define the behavior. So
you can define it. There are usually two ways to do it. You can do it in XML, or you can do it in Java. So yes, you could do it in manifest and specify that an activity is a single top activity.
in what case you choose one and set right? That's where it
Well, typically XML and manifest is static. So when you define something in there, it's like that for life of it, right? So it's always like that. You're not really doing things dynamically. You do it in Java if it depends on some kind of condition or something, right? In certain cases, something makes sense to be a single top. In other cases, it doesn't.
How do you choose?
So is it a static decision? This activity is always going to be one of singleton, or is it a dynamic decision? Depending on the state, something needs to be sometimes behave one way, sometimes in a different way. We'll see some of these decisions in a different context, so you'll kind of see the difference between Java and XML. But yeah, we'll talk about that. So far, so good on this, activities and services. Sorry, activities and intents. So let's talk about services. So services are another building block, right? We only have like 4 of them, building blocks: activities, services, providers, and receivers. So a service is something that runs in quote-unquote background, right? So it's not visible. It's typically running, doing something in the background. Now I say quote-unquote background because it's not really running on a separate thread. It's actually running, by default, it's running on the same UI thread that the main activity is running. So it's kind of like misleading that it's actually in the background. And we'll see this as a problem, and then we're going to introduce some solutions to that. But let's say I want to write a music app. Like, let's say I want to write something like Pandora, right? So I do need the UI. I need some way to basically you know, pick a song or station, give it thumbs up, thumbs down, fast forward, stop, whatever, right? So basically, if this is my app, if this box is my app, right? Then in my app, I would have some kind, I would have an activity. It would represent the UI for this guy, right? This is my user interface. That's why I pick this station and click thumbs up, right? But I would not own playing of the music on this, because that would mean that whenever, you know, at some point the activity could be just blown away by the system and the music would abruptly stop playing, right? That's not what you want. So you would not have the long-running tasks be part of the activity. Rather, it'd be a part of the service. So this guy would simply start a service, stop a service, right? So this guy now owns the actual playing of the music.
That's running on UI thread or?
By default, this one is running on the UI thread as well. Yeah, so service is by default running in the same thread as your activity.
So the activity goes away, then the display will go away.
No, it's what goes away is the activity object, right? What doesn't go away is the process that's running all this together. So let me, I'll pull up a slide from this is really from a different course, but it actually illustrates this point a little bit. So your application has a single process, right? Inside of that process, you have a thread, a single thread, right? What happens is a bunch of things happen, right? Like you press a button, that's a UI event. Phone call comes in, that's a UI event. Battery is running low, that's some kind of system event. You know, new tweet, that's another event, right? Bunch of things are happening. Those things are being dispatched to a queue. So a queue is basically a queue, you know, first in, first out, right? So things are basically collected here, bunch of messages, i.e. intents. Remember intents? So they just get placed in this queue, right? So then there's this guy called the looper. Looper is basically just running in a loop. And it picks a message at a time. Takes this message and says, all right, what does this message say? I have to do something in activity. Does something. Oh, okay, I got to start a music playing. Got it. Oh, the user wants to fast forward the music. Okay. Oh, I want to stop the music. And so on and so on. So this guy is the guy that is processing the messages. It does it serially, one by one by one. And that's how things work, right? So what is important about this picture is that this here is asynchronous. The messages gets dropped into a queue. Queue gets bigger, and so on and so on, right? It's just a message, an intent, right? So this is asynchronous. This is synchronous blocking. So while the looper is busy processing an event, okay, nothing else happens. So that's where blocking comes in. We're gonna look into this in more detail once we actually have some kind of, you know, something to demonstrate it in. Okay.
So all activity running inside of one process?
Yes. Well, part of one application. This is one process, one application. Right. So this is my app.
Okay. So from this diagram, the activity service looks like they're in a separate thread.
No, there's the same thread. They're an object that something else drives actions on. That something else is a looper. Looper is its own thread, yeah. So you have, this is just an object, right? It's a Java object. Something calls on create, on start, on stop, on destroy, on process this, and blah, 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 right? So that something that is running is a looper. It processes the messages here. It says, oh, look, I got some work for such and such activity. All right, let me go run that on that activity.
Okay.
Yeah.
Okay, okay, I think I got it. So even activity goes away, the UI thread is still alive.
Oh yeah, this guy goes away, fine. Looper is still processing the message. If another message says start activity, then this guy gets recreated, and so on and so on. Yeah.
Does the looper start specific activities, or does it? I mean, it's kind of getting back to the issue of who handles the map link. Does it go to map, or does it go to the browser? I mean, is that, so in that case, it's not specifically calling an activity. It's saying, okay, this event has happened. I'm trying to open a map link, and then it has to use it which one they want to do.
So the question about who decides which one gets done. So it depends on a message, right? A message is really in a form of an intent, okay? Usually. So it says, here's an intent. Here's an intent. Now, intents, which we talked about earlier. Oops, that went too far. Intents. I here demonstrated intents for activities. So basically, this guy says start something that is capable of rendering HTML. More specifically, it says open up this HTML page, right? Who is gonna open it depends on user's preference. So if there are 2 or more possible candidates that can handle opening a web page, right? Then the system is gonna pop up a window that says which one would you like, and then you can say don't ask me again, I prefer this guy, right? Sort of just like when you installed Safari or Firefox on your PC, it asked you I'm not your default browser, you said please be my default browser, don't ask me this again. Make sense? So conceptually works the same, right? So and when you install a web browser, so you go and you download Firefox on your phone. Firefox says I am a candidate to process HTML pages. Please, 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 next time there's an HTML page, consider me as one of the candidates. Pop up a question and ask the user if the user wants to use me. Right? That's how it works. Now, intents can be directed toward services or activities or broadcasts and so on. They're handled differently in different cases. But activities handle it this way. So we'll talk about the other guys later on. Yeah.
If service is running on the UI bad, if service is like busy, then you will block actual UI.
Yes.
So it will slow down.
Yes, that's why it's misleading, because you think about it. So yes, a service is going to block a UI thread. So you think about service and you're like, okay, it's something that runs in a background. Yes, it's in a background in a way that you're not seeing it, but no, it's not in a background as in a background thread, which is what you kind of think naturally, right? So it's not on a UI thread. It's not on a background thread. It runs on a UI thread, and it's actually kind of hard to spot. I actually didn't know it for some time. I was like, I was just like, why is my app so sluggish, right? Like, what's going on? Why is it not responding? It's hard to catch, right? And then later on, you learn about some profiling tools and stuff, and then you can, well, we're actually going to visualize it. We're going to create that problem, then we're going to solve that problem later on. So, yeah. Cool. So services are hard to visualize, so they just keep on running in the background. Now, services have much easier life cycle. You know, it's basically you started, you stop it. Okay. A typical service is going to run through this life cycle. So it's going to go through on create, on start, and on destroy. So the beginning it's starting, right? It's in running state, and then it's in destroyed state. No, there's no pause, there's no resume, because think about pause is really meant for like partially visible. No such thing.
But audio is can be paused and resume. Audio and video.
Audio and video service can be paused. Yes, but audio and video service are what we call a remote service. It's implemented differently. So to be fair, there are two types. Well, there are two types of services, but there's also two types of usage of one type of service. I'm talking about the simplest service here, just regular plain old service. A plain old service, it could be bound or unbound. Okay, so here I'm talking about the unbound one. I just say start something, stop something. the quote-unquote buttons I can press on it is start, stop. That's it, right? So that's a very simplest service. It's a typical service that's like, okay, start checking for my email periodically. Stop checking for my email periodically, right? Start Facebook update, stop Facebook update, that sort of stuff, right? It's one of those like always on, always running background thingies, right? Make sense? So that's basically what the typical service is. You then have bound services, which there's a sense of essentially like a session, but it's not really a session between the client and the service, right? The activity and the service, for example. And that requires use of inter-process communication via something called AIDL, binder and AIDL, which we're going to talk toward like Thursday, Friday, right? That's a little harder, more complex. But when you do that, you can actually do a much tighter connection between the client and the servers, right? So as opposed to having 2 buttons, you can have as many buttons as you want. Not just start checking my email, but you could say stop music, fast forward music, right? Rate music, thumbs up, thumbs down, that sort of stuff. But that requires a use of binder. That's the thing that we call, so binder provides for IPC mechanism. There's now a sense of connection between these 2 guys, right? Got it? We'll get to that later on. And by the way, user you can see services that are running. So if I go home, menu, you could, on the older forms you go system settings, application, blah blah. Here's actually, I think you can do it right from here, so it's a little shortcut. Running. And so basically you can see what we got, running. You can basically see what we've got. So basically I have one service as part of the Android keyboard, right? Okay, so that's a service input method keyboard. So I could stop it if I wanted to, like I could basically say stop this service, right? So that's where services would be reported on a standard device. If I take, this is my consumer phone. If I connect my consumer phone, nothing special phone, right? So if I connect my phone via USB cable into a this, and let's see if it fits. What I can do now, I can just do this. I can go to DDMS perspective, and I can actually, so see how it shows now online, right? We're agnostic to physical versus emulated, right? I can actually grab a screenshot from the phone. Oh, maybe I should like open up the. So this is my lock screen, right? So let me unlock it. So let me then go this. Now it doesn't. I have to keep on refreshing it, so I have to do the refresh. But you can kind of, you know, see that. So I can go, for example, oops, settings. And I can do applications. So I can do running services, all right? So I'm clicking on this guy here, running services, right? And now you can see that I have a lot of services on a standard phone, right? Like look, Google Voice is running there, 2 services. Facebook, 1 service. Android Open, I don't know why it's still running as a service. Win Companion is running there, right? So, you know, the list keeps on going. Like, I'm just halfway done, right? So look how many things I have going on. HTC Sense, Google Services, Telenav, Jesus. And all these guys basically are running there, right? Backup service is running, touch input is running, maps is running, right? So they're all doing something in the background, right? Oops. So Maps has been running for, I guess, backup. This is how many hours? No, this is minutes. So 600 minutes. Yeah. So that's when we want to know why your battery is running low, right? That's because of all this stuff that you have going on in the background, right? Okay. So do you guys understand what services are then? Always on, always running stuff, right? So that's basically what that is. So let's talk about the content providers. Let me this is very noisy, so I'm gonna do this. So content provider. So content providers are basically another main building block, and it's a way for you to share the data between your apps, right? So your apps live in separate sandboxes. One app cannot access the data of the other app, right? They can't just poke around. It's a security, that's a basic security sort of paradigm of Android. Each app is like a Chinese wall around it. Like you can't just access it, right? So what if you do want to share the data? What if I want my Twitter app to share the data with my Facebook app, with my contacts, etc., etc.? So you have the option of piercing a hole in your app and exposing the data, right? And basically you do it via content provider, and all content provider essentially is your simple CRUD interface. CRUD stands for create, retrieve, update, and delete. So when it comes to data, that's the only 4 things you can do with the data, right? Create data, retrieve data, update data, and delete data. So we call that basically insert, update, delete, and query. Those are the functions that we have, or the methods, or the API to content providers, right? So system uses this quite a bit. Like for example, I go out and I take a photo with my camera app. Well, I would like this photo now to be in my gallery, so that my gallery app can see it. I also want to take this photo and send it to my buddies via Gmail, or maybe upload it to Facebook via Facebook app, or maybe share it via Twitter. Right? So lots of things I care about this little photo I took. Right? So content providers make it possible to share this data. So here's another example of how that looks in the system. So basically, if you take address or contacts app, aka address book, right? You don't have one app, you actually have 2 apps, right? You have one app that has the UI. So this app is all about just having a UI, the activity, right? So this is your user interface. You have the buttons and you have the pictures and all that stuff, but no data. Data is actually being served by this guy. It's a provider, right? So this guy now serves the data, exposes it via content provider to the UI. Right? So we're decoupling concerns. We could have all bundled it in, but then we would have less of a flexible system, right? We decouple it, so there's an expense of doing this, like decoupling, right? Like anything else. Things are much simpler when you just put everything in the same box and so forth. But when you want to separate it, there's an expense to it. But flexibility is awesome, because now you can have somebody else come and write another app, that has another UI that actually talks to the same guy, right? That's what for example, HTC does. It creates, the sexier version of address book, right? But it leverages the same data. So it's not like you have 5 databases for your people. You actually have one database. Not only that, but because now things share data, you can basically have your contacts be augmented with your Facebook and Twitter information and LinkedIn information, Microsoft Exchange information, and so forth. So you can build this kind of like a holistic view of Bob, for example, right? Which is really cool, right? So HTC Sense, for example, takes advantage of that quite a bit.
So your app has to be running in order for other apps to access that.
Well, so does your app have to be running? Content provider is going to be automatically created as needed to serve content and disposed of when it's not needed. Yeah.
Can you specify in the content provider what app can or cannot access it?
Can you specify who can access it? Yes, you have certain mechanisms of controlling that access. One is to set up a permissions statically. You blanket not give it to anyone else except just those who are allowed. You can dynamically also check it. So there are multiple mechanisms. You know, one way to think about content providers is that you access it via something called the URI, which is similar to a URL, right? So just like web is all public, right? You can go to any URL, yeah? That's similarly content provider, you can go to any any content data provider, right? Any data source. Now, it doesn't mean that it's going to give you much. So the fact that I know some customers, you know, Bank of America URL doesn't mean that I'm going to be able to see the data, because it's really quickly going to bounce me to a login screen or something similar. Exactly, yeah. So there's although it's web is all about public access, right? We know mechanisms how to control that. Simple sessions or tokens or cookies or any of those mechanisms work on the web, right? So similarly, we have similar mechanisms available to us with content providers, and we're going to explore them later on, yeah, as we keep on going. So our final piece of this is final main building block is something called broadcast receivers. So broadcast receivers are basically your publish subscribe mechanism, okay? Or if you guys are more familiar with design patterns, this would be observable pattern, right? You have something observing something else, right? So, kind of, because in observable pattern you basically have a it needs to be more dynamic, whereas publish subscribe you can be static. So to explain this, I may have some piece of code. I want to register this piece of code for some kind of event, right? Like for example, we care about SMS arriving. We care about system running low on battery. We care about network disappearing, not being available, and so on. Like the phone is a very noisy place. There's a lot of sort of broadcasts going on all the time. So if you care about such a broadcast, you register yourself for that broadcast. When it happens, your code wakes up and gets notified. So otherwise, your code is dormant, right? It just sits there. Something it registered for happens, bam, it wakes up, does the job, it goes away. Yeah. Yeah, it's exactly, it is a publish subscribe mechanism. Yes, exactly. We just call them broadcast receivers, but it's a publish subscribe mechanism. Yeah, so the question is about the broadcast, how to basically, if you have an external device, how to have that external device notify some piece of code about something, right? Okay, so you have choices here, right? And this is where it becomes, you know, the design of an app is more of an art than a science, right? So you have a choice. Like, I'll give you an example. I could compare that to sensors, right? So sensors don't use this. Like, for example, if I want to know when our magnetic field changes or orientation changes or, you know, temperature changes, so whatever the sensor is, right? It doesn't work that way. Nor does GPS work that way. It works this way. Uses the this mechanism. So you say, I want to know when my location changes. You register yourself for updates, and you keep getting these updates, keep getting these updates, keep getting these updates, keep getting these updates, keep getting these updates. So it's a push, like all the time, right? Like it could be, you know, many times per second, right? So it uses remote service, it uses AIDL binder IPC mechanism, right? It uses that, okay? So it's a different mechanism. On the other hand, like let's say, for example, NFC, near field communication, like you want to do something like that, right? That doesn't use that mechanism. It uses the mechanism of broadcast receiver, where you basically say, I want to be notified when an NFC device is in the area, bam, notifies you or something like that, right? So why would you in one case use one versus the other mechanism? The fundamental difference is asynchronous versus synchronous nature of this, right? In other words, how quickly do you need this response, notifications, right? So this stuff, this communication here is synchronous. This guy is now going to directly call to this guy and say, something happened, something happened, something happened, something happened, right? So it's synchronous. Until this gets processed, it sits there, it's waiting, it's blocking. This guy is now blocking for that callback. Okay? Whereas in this case, the nature is asynchronous. Something happened, this guy is gonna, at some point, send a broadcast to be processed. Well, it's gonna send a broadcast right away, but that broadcast is gonna sit in a queue until it waits its turn. So it could be like a couple of cycles, right? Battery is running low. All right, in a couple of seconds I'll find out about that. No big deal, right? SMS arrived. A couple of seconds I'll find out. No big deal, right? But if I'm playing a video game, right? It's like, you're playing like, Fast and Furious or something like that. It's like, oh, there's a wall. I better like, I want my car to turn. Otherwise, like I end up in the wall, right? So asynchronous doesn't cut it for playing a video game, right? Make sense? So you have many ways to communicate, but one makes better sense in some cases than the other. So scanner, it really depends, how you would do it. We usually do the async. We actually have a similar example for our internals class. We actually build something from top to bottom that controls a device, like either barcode scanner or a missile launcher. But we use the remote services binder. So that's basically broadcast receivers.